Hi guys, welcome to CodeWide, and again I'm back with another question that is linked list cycle 2. It's a medium level question in lead code. So before I start the question, I want you to read the question on. I hope you read the question. So let's take an example like what they're asking. Basically, they're just asking you to return the node if there is a cycle, or else return null. So, for example, this is the first example. In this, we can see that the last node is connecting to the first index. So we output that the tail connects to the node index 1. In this, the 2 is connecting to a 0th index, so tail connects to a 0th index. So in this, there is no cycle, so we just say no cycle. So, okay, fine. So, how are we going to solve this? So, we are going to solve this using the famous approach, that is using fast and slow pointers. I have already said in my previous video, in the pattern recognition video, that wherever there is a cycle question, just first think of fast and slow pointer, right? So easy, and it makes the code really look simple. So let's just see how we are going to implement it. So let's take the same example, that is 3, uh, 2 and 0 and -4, right? Okay, so this is connecting back to 2. Cool. So how can we find if there is a cycle or not? So for that, as I said, we are using slow and fast pointer. Why we are using slow and fast pointer? Because it's obvious that, for example, if we take two pointers which goes in one speed and other pointer goes in 2x speed, right? For example, let's assume S is a pointer, it's a slow pointer, it's going with x speed, and if f is going with 2x speed, we know that if there is a cycle, we are pretty much sure that at any one point, it's going to coincide, because one is going 2x of the speed. So it's obvious that if there is a cycle, if the slow pointer here is here, it will be right? One will be going slow, other will be going fast. So it's obvious that at some of the point, it might coincide. What do I mean by coincide? That it meets. So if that happens, if both are meeting, we can say, right, yeah, the cycle exists. Because if there is no cycle, f should have been null. I mean, for example, let's take example like 3, 4, 1, right? This is the list. So if there is no cycle, f f f is the fast pointer, right? So it should have been null. Next will be pointing null. Like if there was cycle, it would have not been none, right? It would be have been traveling, right? I hope you're getting. So okay, you might ask now, okay, fine. We are using fast and slow pointer to figure out if there is a cycle or not. But how we are going to figure out if there is a node, in which node it's coinciding? That's a good question. So what we are doing is, uh, let me just erase this. Cool. So by observation, like if you just run the fast and slow pointer for this example, you will see that at this point, slow and fast pointer will coincide. You can check if you want. So at this point, it will coincide. So it's obvious that there is a cycle. Yeah, we got it. Fine. If there is a cycle, what we do is, now we have to find at what point the edge is starting, like at what point it's creating. So for that, what we do is, uh, we take a temporary variable as head. We take a temporary variable at head, and we start moving the temporary and the slow pointer until they coincide. How is this? There is a theorem. I am not going to prove that. You can study in Google. that it's a theorem which basically, like, if you're starting the temporary variable and the slow pointer, like that the slow pointer and the past pointer have coincided in this point. So we leave the slow pointer, we start the slow pointer from where it coincides, and we start the temporary variable from the start, and uh, we move it till it coincides. Where it coincides, that is our node. I mean, where the cycle is originated. For in this case, since we know that slow pointer and the fast pointer have coincided here, so we start the slow pointer from this point, and we start the temporary pointer from this point. So we move it by one, that is slow next. Slow next will be here, and temp next will also be here, right? You can see that in this point it has been coinciding. So we will return this as the node where the cycle has been uh, starting. If you have any doubt, you can also try with different example. However, the theory is not going to change. You'll get the node where it's originating. So in our case, this is the node where the cycle is originating, so we return this. I hope you are understood. Let's see the code right now. Have already written the code. So basically, we are taking, as I said, we are taking slow and fast pointer at the head, and we are moving. We are checking if the fast and the fast next is not null. If it is null, we know that return null because there is no cycle. So until there is cycle, I mean, if there is cycle, it goes inside, and as I said, slow pointers move by one, and fast pointer moves by two, right? So at the point where f is double equal to s, as I said, in our case, this will be the position. So at this point, what we do is we initialize the temp to head. We start over temp head, and until these two are equal, until temp is coinciding with s, we start moving s and temp by one step. So we know that when temp is double equal to s, it comes out and it will return s, because that's the point where temp will be equal to s. So at this point we just return s, because s will be the point where the both are coinciding and where the cycle is originating. So yeah, or else it will return null if there is no cycle. I hope you have understood the solution. This is a pretty easy problem, and the concept, basically the concept makes it simpler. As I said, if you have not checked that video, the pattern recognition, I do recommend you to check that one. It's a more important video. So yeah, if you like the content, do like the video and do subscribe to the channel for more updates. Yeah, thank you. Keep coding. Bye.